Hello everyone, we are Pet Zone, and today we are going to introduce our project which is the automatic pet feeder. And so this thing is it helps pet owners to easily feed the pets while the pet owners are not at home. Also, like through our machine, you could do a real-time communication with the pets. And so we have like time feeding, manual feeding, audio and video real-time communication. And we also have like record voice commands. So let Yuan go for the engineering challenges that we have.
Yep.
Okay. For our product, there are many challenges we need to face for design our products. First, we need to determine a proper dispensing method, like should we use a DC motor or servo motor? In the end, we decided to use a servo motor instead of DC motor because servo motor is easy to control and the rotation angle is more accurate. And then we need to consider what size of pet food our food should be suitable for. Also, we need to figure out how to make real-time communication through internet and how to make the real-time communication more synchronized and smoother. How to control the machine using the browser and the record and display sound are also some challenges for us. So let me introduce Anton to our product.
Okay, so for our hardware and software, we use the Notepad, Smarty, VNC Viewer, and the Raspberry OS. So for our hardwares, we use the 3D printer to print the inside of the food container, and we use the servo motor, Raspberry Pi, speaker, audio, camera, and like 50% of our product is environment friendly. And for next part, I will go back to you, Shanhan.
So as you guys can see in this graph, like we mainly so this part we use this to contain the food, the pet food, and also there's a dispenser down here, which is this part. And so in order to let the food come out, we have a food slide, and down here this is the food ball. And also this is we mainly use we use another material for the outer shield, and this is our block diagram. So our goal is to use a smartphone, which is open HTML, which is a browser to control the machine, and we connect the USB camera and the USB microphone to use for the video and audio part, and also we have the speaker just to output the voice. And the servo motor is used to control the food dispenser to release food. So now let's go through the real demo. So first we're gonna demo the real-time communication. But this thing, I mean, it depends on luck to make it a success, because the processor is gonna be very very hot, and the camera just gonna turn black. So that's one of the things we need to solve in the future, which is install a cooler for the Raspberry Pi. So I'm gonna bring the camera, and you can see, like here we're actually moving, and there's now the voice comes out. Can you just adjust the voice just to make that thing? So you can see the camera is actually moving, right? And here, and I believe you guys also see that there's another black screen, which has things in there before, because the processor turns really hot now, so it couldn't process anymore, and it caused it just to turn black. And here comes the echo. So I'm gonna plug back the computer to show you what we recorded before. What? Sorry. So this in this video, like we're doing the real-time communication in our home. As you can see, the computer is showing Xiongfeng's face, and later on the camera. This camera is also towards Xiongfeng's face, and it shows a face, right? And I was using a cooler just to make the processor to cool down and to make the camera move. But yeah, I mean it's successful, but just the hardware couldn't let us to do it very smoothly, and it will cause some problems to come up. And now we're gonna demo the feeding. And all the real-time communication is actually done through the internet, not through in the same Wi-Fi.
You want to control here or here?
Oh, you can control it. So here is our web controlling website. It's the HTML control manual. Like we have manual feeding, video, audio, and time feeding. And also we have 2 pre-recorded audio just to do a demo, like to show the pet owners that you can record anything in there, like any commands. And Xiongfeng will do the manual feeding first. Can you put the things in there?
So this is the fat cat food.
So actually we forgot to bring the cat food today, so we just picked some parts in the lab and just to pretend it's a cat food. Yeah, sorry. As you can see, it dropped, like the food dropped off from our food container, and that's the feeding part. And now we also have a video for the under a same Wi-Fi. Xiongfeng can show it to you guys. As you can see, right? It's working. This is under the same Wi-Fi. This video is. Yeah, it worked. And now let's go through the next part. Next one is the time feeding. Like currently in the program we set up is like after 10 seconds the machine will release the food after 10 seconds. That's currently in our program, and Xiongfeng can demo it.
The gun will 10 seconds.
Yeah, after 10 seconds the food will release.
10 seconds.
Yeah, it worked. So so when the machine comes to the pet owners, they can decide whenever, like maybe 10 hours or 8 hours to release the food, and it will work. So next part we're gonna demo the recorded audio. So we pre-recorded like 2. One is a cat voice, another is a dog voice. Yeah. Sorry, the voice is kind of low, but you can't actually hear it. Did you try to turn up the voice to max?
This is the maximum.
Okay, sorry. And the second voice is gonna be different. It's gonna be a dog bark.
It's over here, I guess. I can control it.
Yeah, sorry. The machine currently is overheat now, so it will sometimes I think it cannot handle too much process at the same time. Yeah, so that's the reason why we need a cooler for it. So, okay.
It's frozen.
So, now I'm going to talk about the future development. So as we said, so we're kind of thinking about using a servo motor or stepper motor or DC motor during our designing part. But at last we use a servo motor. But we still we did some research online and we found out maybe a stepper motor or DC motor is going to be better. So that's maybe in the future maybe we could do some changes on the dispenser part. And another thing is the redesign of the outer and inner structure. We think currently our structure wasn't perfect because sometimes the food will stuck if the food is very small, not big enough, so it will kind of stuck. But currently it's working now, and that's the redesign, the thing we need to redesign. And the last part is install a cooler. That's the most important thing I think for our project because Raspberry Pi couldn't took too much process at the same time, so it will cause program to stuck and maybe overheat, so we could not finish our real-time communication. And that's all for our project. Thank you.